So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks, which says some pair closest to target. So what this problem says, it is saying that we are given an array, and for that array we all also provided with a target. We need to find two numbers a and b in such a way that these two numbers when added are closest to this target. So if I have these two numbers 10 and 20, the sum is 30, which is pretty much close by 5. But when I have this 20 and 5, then which means I am having 25 exactly. So my answer would be 20 and 5. But there's a catch once more, that we need to return this within a sorted array, and so if it is 20 and 5, we need to return 5 and 20 because 5 comes first when sorted. Again, if there are multiple such occurrences, instead of 20 and 5, there would be like 10 and 15. Then the answer still would be 20 and 5, because the answer is, we wanted to find the answer such that both the numbers have the maximum difference between them. So maximum absolute difference, and the sum should be closest to the target. So this was about example 1. Similar goes with example 2, and similar with example 3. But in case of example 3, there are no such elements, so we return an empty array, which is pretty much expected. So I'll just twist one of the case over here. I'll just copy it over here and paste it in such a way. So if I have an array of a form like this, and my target would be 11, in that case the result would again be 20 and 5. Sorry, not 11 but 27. It would be 5 and 20, because we maximum have that 25 is much closest to 27, which we can go ahead. If it was by any chance, if the target was 30 or 28, let's take 30 in that case, result would be 1020. Again the target would have been like, let's say 40 in that case. Result would have been 1030. Even for 41, 1030, 42, 1030, and so on. 45, we have a tie between result is 1030 or result is 2030. But as you see, that 1030 is much more closer, because it has plus 5 difference and it has minus 5 difference. So when you add 20 and 30, the result is 50. 50 minus 5 is 45, and this is 40 plus 5 is 45. So but we are choosing the array 1 because of, obviously, because of the longest distance. So these are some of the use cases which you might miss, but we also need to check one use case. I'll just write it down, that check empty or insufficient array, that is length less than 2. Well, having said that, we have thought of the corner cases. Now let's check upon the approaches. While checking for the approach, the first and foremost approach we can go ahead is brute force. With the brute force, we take each element from I, element from array with rest of element, having the overall time complexity of O of n square. But this is not very viable solution. What can we do next? Well, we can have something like Hashing, would hashing work? uh, Hashing might work for a certain extent, but you are not certain that whether I will get the perfect answer or not. What do I mean is, if I have a target as 30, in that case, if you find 10, you just need to check 20 exists or not. But what if for 45, you need to find 10, then you need to check for any of the characters like 25. Sorry, not 25, 35. But we don't have 35 over here. We have 30. So that doesn't work over here. So closest thing to hashing would be sorting and search and find. So sorting and finding would be something like, if I'm having 10, I'll go ahead binary search within the array and figure out where I am, where I need to search. So keeping one element fixed, search for, or I'll say binary search for the counterpart. As you know, as you find out the location plus minus 1 would give you the near sum. So the nearest sum can be found out by this, but can we do something better? Obviously the time complexity of this would be O of n log n plus sorting. For sorting we have n log n. We need first of all sorting, which will go to n log n, and we need also n log n time complexity, because for each one element we are having a binary search. Well, within the approach 3, what's going on here? We are keeping one element fixed. Can we move that element as well? So what I mean is, have two pointers where L left and right. Left moves within this direction, and somewhere here our target lies, and right moves in this direction. So as per the target, or as per the actual sum which we want, left hand pointers are moving. So if we wanted sum as 45, we are moving right from, let's take this array only. The array sounds something like post sorting 5, 10, 20, 30. So initially I'm having left over here, right over here, and the sum is 35. Oh, okay. And for the target which I'm expecting is 45. Let's take this example, the last one. Now for the target 45, I see 35 which is smaller. I need to go to the right direction because I wanted to have a bigger number. So I'm going here, go get big. That means L++. So if I have this and this combination, so it is 10 and 30, which is 40. So that's good, but can you get big again, which means L++. So I'll say, well, L++, then take L and R both again. So it gives you 20 plus 30, which is 50. So get small, because 50 is too much for this, R minus minus. And here we go, we have 40 and 50 both into the consideration. Now it is up to you whether to take 40 or 50, but as per the problem says that choose the maximum difference. We are not going for 50 and we are settling for 40. So we are heavily checking on if and only if we found lesser difference, we update the results. Now in this case, we are pretty much clear. Our solution will be working. And even in the case if we got element like 35, 40, we are pretty much solid enough to return any of the combination. So let's begin with the implementation. I'll pull this up, and keeping the corner case in mind, if just change the variable name as a dot length is less than 2, then return new array list, and that's it, empty array. I'll have result is equal to new int of 2 because we need to find out two values, and I'll have left is equal to 0 initially, and right is equal to a dot length minus 1. While I see the left is less than right, I need to check and iterate. So check for the initial sum as current sum, which is equal to a of L plus a of R, and we have existing difference, which is equal to match.abs, because we need to find the closest difference, right? It may be positive, negative, but we need to find the closest. So target, or I'll say a of result of 0 plus result of 1, which is the sum in our case minus target. And if we see that, hey, the current sum, or let me just boil it down again, that current difference is equal to mat.abs current sum minus target. If you find that current difference is less than existing difference, my dear friends, it is time to update. If and only if we found lesser difference, we update. So if we found lesser difference, let's update. Result of 0 is equal to a of L, and result of 1 is equal to a of R. See the beauty of sorting. As it is sorted, we are guaranteed to have a of L smaller and a of L R larger. So we are expected to have it result as sorted at any point of time. And if we see sum or current sum, which is lesser than target, then we know the drill. It is lesser, then get big, L plus plus, L plus plus, else R minus minus. And that's all about it. Ultimately we return the result, but it is expected as list, so I'll convert it into list by arrays dot stream. Okay, let's not use stream for just two integers. I'll just say hard code it to new array list, and within the array list I'll just go ahead and say formatting like this, yeah, add result of 0 and add result of 1. This is a static way of initializing the array. It comes very handy when we have two elements. You can also use list of function, so you cannot find add, that's weird. Okay, we don't have this, we have result. Okay, let's submit this and check. So the time complexity as okay, it says I'm missing something. Ten of 5. Okay, sorry, if the existing difference is greater than, that's correct, current sum minus target, this sum minus target. Okay, well, result we haven't initialized it, right? So result of 0 initially is equal to a of L, and result of 1 initially is equal to a of R, because the initial values of result would be 0 and 0. 0 minus 0 would always be the optimal. Something is missing because we haven't sorted the array. So let's sort it. Yeah. And yeah, so obviously uh, it that isn't sorted, so we need to sort it array. Sorting I have missed, and here we added it now. So yeah, we have passed rest of the test cases. It was a part of two pointer solutions, and it has been asked into this company's topic tags. You can see two pointer algorithms, a part of data structures and array. So for more such company related and solutions related to two pointer, click the video on your right, and I'll see you in the next one.